Section 1.2, Science in Context. At science again, a process, and where we're looking at exploration and discovery. So how did people discover these things, and where did their ideas come from? First of all, you have to have a scientific attitude. In other words, you have to always be questioning things, maybe be a little skeptic. Do you have a scientific attitude? Because if you do, this attitude is what helps generate new ideas. So what attitudes are we talking about? What would be considered a scientific attitude? Well, curiosity is one. Skepticism, open-mindedness. You have to be open-minded and keep your mind open for new ideas. And you probably have to be a little bit creative. So do you have a scientific attitude? Now, these ideas are closely linked to exploration and discovery. As always, and as we said before, it's always going to start with observations and questions. Those observations and questions are usually inspired by your scientific attitude. You might be looking at practical problems, or you could even be looking at new technology, something to make your life a little bit easier. And from these questions, you usually get your question, obviously, your hypothesis, and from that, with your creativity, you can test your hypothesis with an experiment. An example that was given in your book was a problem of people that live on a strip of land along the coast may face flooding and other problems. So that's a practical problem, and so having a scientific attitude or being creative might help someone to make a plan or to make a fix for these flooding problems. Sometimes it doesn't have to come, it does come from being curious, but it also, you may not necessarily be looking at the original problem that you were testing. So what's serendipity? So serendipity is when something good happens by accident. Okay, so you may or may not have heard of Alexander Fleming, and he's known for discovering penicillin, and you know that penicillin is an antibiotic. But basically what it was an observation that he made. He was studying bacteria, but in fact what happened was some mold had grown on the petri dish, and he noticed that the bacteria didn't grow next to the mold. It was growing everywhere else on the plate, but not next to the mold. And because he had this questioning attitude, it allowed him to figure out that maybe something in the mold was killing the bacteria. So when we're looking at science, you know that science is closely linked with technology, also linked with our society. Because of technology is why we're able to live that we live. You know, it was originally science. That science, like I said, is linked with technology, and the technology is usually used to help society. So it might be used in medicine or something like that at first, and then it's transferred to society in ways that make our life a little better. Things like Teflon, the nonstick coating on pans. That was originally used, I believe, on spaceships. The internet was originally made for the military to communicate. Then it went to academia, or rather for education, and now it's really, really entwined in society. So basically what happens is that you might have a discovery in one field of science that helps with making some type of new technology, and then scientists in other fields, because of the technology, are able to ask other questions, and then they might gather data that has to do with their field. So technology can impact daily life. A good example is the ability to mass produce vitamins, antibiotics, and hormones. It used to be that the only way you could get them before was naturally. Now we're able to actually make vitamins and antibiotics. Now, other than using it for technology, you have to understand that once you come up with this data or your conclusion, scientists have to communicate those results. And when they communicate them, they give them to their peers. In other words, they might put it in a journal, and your peers or other scientists in that field will review the information. So why do you think that it's important? So why is peer review important? Well, it gives a chance for researchers to share their ideas, and also other scientists can test and evaluate their work. Now, how do they share this stuff? Like I said, share it by publishing it in journals. Like there's a journal of biology, there's a journal of anatomy and physiology, there's a journal of cell biology, there's a journal for physics, quantum physics. They have journals for all types of science. Now, once they publish it and it's been peer reviewed, scientists might have other questions. Remember earlier when we were talking in the last section, we were talking about the marsh grass and that nitrogen helped with the growth? Well, one question that it might spark would be whether or not this nitrogen limits the growth of mangroves. This is a picture of a mangrove, and they have roots that are above the ground, and they're usually like in swamp areas, places like that. Scientific theories. Okay, so what's a scientific theory? Is it considered just a theory? Well, in science, when we say theory, it's a really, really big deal. Okay, so a theory would be an explanation, or you could say maybe a hypothesis, but it's been well tested. It may even cover many hypotheses and observations, and it enables scientists to predict what will happen in other situations. So first of all, scientific theory is going to be thoroughly tested and supported. It's going to be the dominant view, so almost all scientists are going to agree with it. But you said that a theory is not the absolute truth, because science is always, we said that in the first section. I gave you a picture here of Albert Einstein because he's kind of famous for different theories that he's come up with, and one of them is the theory of relativity, and another one is that famous formula called E equals mc squared. So when we're looking at theories, understand that it could change, because remember there's new evidence, new technology can come up, so it can be or it can be replaced by a theory that's maybe more useful. Big deal with science. Well, science and society usually work hand in hand, and one thing that's important is that you have to learn about science, because you need to know about its limitations and what the context is that we're talking about. So sometimes you have scientific questions, and these questions involve society. So it might have something to do with our economy, it might have something to do with our laws, it may even have to do with your moral principles. So you understand that science is separate from ethics and morality. Okay? So if a scientist understand that science explains why, and we're only talking about the natural world. We're not talking about a person's viewpoint. We're not talking about their ethics. We're not talking about what they feel about it. It's just whatever the data shows. So that's why they always try to explain things in scientific terms. So even though they can explain it in scientific terms, they're not going to answer questions like why does life exist, what the meaning of life is. There's like a definite separation between those two. Science only talks about what can be proven. Okay, so they don't get involved in any arguments about things that necessarily can't be proven by experimentation. Another thing that science tries to do is that when running experiments, scientists try to avoid what's called bias. And that's when someone has a particular preference or a point of view, and they try to skew or try to move the experiment so that it proves their point. And that would be considered bias. So you want science, or science wants to be objective. So here I put, sometimes scientific data can be misinterpreted or misapplied by scientists who want to prove a particular point. Especially if money's involved, especially think about drugs that cure different diseases. You know, they want to hurry up and get their drug approved so it can be given to people, because once it's given to people, then they can make a lot of money off of it. So sometimes science may not be as objective as they need to be. So what about you? You in science, you can't just memorize the facts. What I want you to do in this course is I want you to understand about these ideas. I want you to try to be able to think about these ideas and put them into a context that will help you. Now, why else do you learn about scientists? Well, first of all, you're going to be voting in a couple years. Probably about maybe 3-4 years you'll be voting, and your vote matters, and it will influence public policy. So things like abortion, things like stem cell research, genetic testing, who should get genetic results, things like that. You have to understand what these discoveries mean, what the terms mean. You may even be a juror on a trial, and if you don't know what DNA is or the limits of DNA, you may not be able to make an informed decision.